Okay, welcome to our lab today. We are going to be doing a lab with a force table. And a force table is a circular disc, and it is marked, I'll show you right here, with 0 to 360, with every degree is marked. So it's very precise, and it's on just a stand so that we can have some hanging masses and turn them into weights. And those weights will be our forces on our force table. And we have some pulleys here. These pulleys, if you remember from our discussion before, a pulley is something that can take a force and change its direction. So if I have a hanging mass, which with gravity turns into a weight, then when this hangs and puts a force down, we can turn it over the pulley wheel to have tension in the string horizontally. So we can turn a vertical tension into a horizontal tension, which is really nice. Now notice I have nothing else here, and yet everything isn't falling off, because this wonderful little way of doing this is that there is a ring here and a pin to help this from sliding off while you're positioning other weights. Our goal is that we're going to be putting all kinds of forces in all kinds of directions, and we're trying to make a equilibrium situation where all the forces cancel. So we're going to have 2 or 3 forces that are going to make a resultant force, and then we're going to have one pull in the opposite, exactly equal and opposite to the resultant, so that all the forces cancel. So we have the resultant forces, the forces that make the resultant, and then one force that's going to make the equilibrant force, because it's going to equalize everything. All right. But this little round circle keeps everything from falling while you're working on getting all these other strings with their masses. And once we do it right, this little round, basically like keychain holder, is going to be exactly in the middle, and we can tell that all the forces cancel because it's not going to be against that post pulling in one way. Okay. All right. So let me take this mass off for right now. I'm going to do the scenario number 1 first. There's something, the part I don't like about this force table is that the forces here are marked. Here's what I don't like. I'm going to put 0 where it normally would be, to the right, to the positive X direction. This thing counts this way, all right, where 90 degrees is south. I think that's going to really screw up your numbers and everything and your perception. So I'm going to say, when I give the numbers in the data table, you're going to put them I'm going to put them in the place you normally would know. When I say put a pulley at 60 degrees, we're going to do it 60 degrees north of east, or up from our 0. So on this ring right now, I don't know if you can see it, I put the first pulley at 300. Okay, so I did 60 degrees above 0. Okay, I think if I don't do that, we're going to really get our signs and everything confused. So I put my first pulley. It also says for this first trial, we're only going to have 3 forces. So it says take 2 of your cute little strings. I'm going to use this one because I think I can move it a little together. Okay, I'm going to put 2 strings over one of the pulleys that's back here. And then it said set the other pulley B, at 120. And 120, if this is, so 0, 90, 120 is going to be actually where the 240 mark is. And I'm going to put my little string and little loop over that one. And then I still have to place my last pulley here. And it says place the pulley E, and I call it E because it's the equilibrant. It is going to, this one pulley is going to enforce, is going to cancel these other 2 out in this position. Now it's placed at 270, and you might be able to see already the symmetry of this design here. And I'm going to do a close-up in just a minute so you can see. But you probably, if if you know already some of your sine, cosine, and your geometry, would realize that this is a perfect place to put the last pulley. Okay, so put that pulley. I'm gonna put my little string over the pulley. I'm gonna try to orient. Okay, I think that's the best I can get this oriented. All right, so here we go. So here we have our 0. This is 60, 120, 270, even though it says 90, right? But you can pretty much get an idea of that. Okay, now the next step says we are going to place a 200 gram mass from pulley A and pulley B. So I'm going to take a 200 gram mass. This one's 200 from pulley A and pulley B. That's back here. I know you can't see them hanging. All right, but we know they're there. Can you see that tension in that if I let go? All right, so now I need to try to put put something here. So now it says, using trial and error, add masses to pulley C so that the ring is centered over the pin without touching the pin. Okay, you might have to adjust and pull lightly to check. So right now, obviously the force is a lot this way. Does anyone have any idea? Can you do some math and maybe figure out what we need? Do you think 200 is going to be enough over here? I'm gonna put 200. And if you can see, that is not centered. So that means I need to add some more. What do you think? Should I have 400? What if I have 400? Is that the same masses? Okay, well, I don't know if you just saw that, but when I put 400 there, 200 and 200 with vectors don't add to 400. Do you see what happened? It pulled it way, it's against this pin. All right, I can try to show you a little close. That is too much force. That is too much force. So that's not gonna work out. I'm gonna take off that 200. I'm gonna put a 100. That's not enough. I'm gonna add a 50. Ooh. Let's see, that ain't bad. Let's see. Yeah, I think that's working out. So now, well, this is one where we don't actually have to read the dial because this dial, that was what I asked to set. So those have been set. So all you need to know is what is hanging here. So what did I do to make this align perfectly? I have a 200, a 100, and a 50 all hanging together there. All right, so we just completed trial 1, and you will place that information in the part 1 measured pulley. So in this part of the lab right here, okay? And then you're gonna do some calculations on that. Okay, so now we're gonna move on to part 2. All right, so now we're gonna work and do part 2. And part 2 says we're gonna put 200 gram masses on all 3 of the pulleys. So that's a little bit different. So we're not adding masses to make the angles chosen work out. Instead, we are gonna have 3 known masses or pulls, and we're going to set one pulley at 0 degrees, and these other 2 we're gonna move so that we get all the forces to cancel, okay? So my first step, get my 200 gram masses. Again, my brass ones look a little bit different than my other iron ones, but so I'm gonna hang 200. That pin is keeping everything from falling off this table, right? Because obviously, do you see that this would never work out, right, with physics, with vectors? This is surely not the correct angles to make things cancel. So this is the only one that it says set is at 0 degrees. Now, hopefully you realize I need to scoot these in this direction. Do you already know? Do you have any idea where they should be, by the way? Right? Well, this is, again, it's not gonna work. That's not equal and opposite, right? Anyone have an idea what we could do here to make my 200 grams work out? All right, do you see it's still, that's not in the middle, is it? So I'm gonna keep working. There's a bit of symmetry going on here. I bet you might be able to figure out what I can do. All right. Did you just see that swing? Did you see this go from I'm hitting to I'm not hitting? Do you like that magic? Look at this. Do you see this? Do you see how it's pretty much free floating in there? That means I made all my forces cancel here. All right. So I have my 200 grams from all of this. This is at 0. Do you know what the magic numbers are? All right. This one is reading 120 and this one is reading 240. I'm trying to think. Again, you can choose to use these as the numbers they are, I guess, or you can use them at well, I guess they are what we are. So this right here, I know it says 240, but this is where, according to our normal directions, this is at 120, okay? All right, and then you can see this one down here is exactly, I don't know if you can see that, at 120. And that would be for us normally, this is 180, right? And you would count down and this one would be 240. So they're just flip-flopped in our situation right here. Okay? All right. And so now that you're gonna record that information in this first chart here, and then you are going to do the calculations for the rest. Okay. All right. So then we're gonna go on to part 3. All right, so now every time it gets a little more tricky in what we're doing here. This time we are gonna have both an unknown angle and an unknown force, all right? So let's read the instructions. For part 3, it says, place pulley A at 0 degrees. It's luckily there from last time, and hang 100 gram mass from it. So I'm gonna make sure I read 100 grams. So I'm gonna hang 100 from that one right there, and you can see it started to pull this off to the side already. Okay, then it says place pulley B at 120, and my 120 is going to be marked with 240, and I need to tighten that down a little bit. Okay, so I have that. This is going to be 120 degrees from 0, and what do I have to do? I have to put 150 grams on that. So I have 100 and a little baby 50, and I'm gonna hang that from the back side here. I know you can't quite see what I'm doing there. Okay, that's hanging from this one. All right, then it says estimate the angle of the equilibrium. So these two are making some kind of resultant force, right? If we use our parallelogram method, vector, vector, there's a vector sum that's in between those. I know then the equilibrant, what's going to cancel out the resultant of these two, would be somewhere in this direction. And so, but I don't know exactly where, and I don't know how much pull. So it's hard to solve for two things at once. So I'm going to solve for one thing at once and just use my feel in my hand to pull. So I'm going to pull, and again, I'm going to see if I can zoom up a little bit here that you can see what I'm doing. I'm going to pull, can you see it's against this, and that's no good. All right there. So I'm gonna pull to try to make this ring go even, right in the middle, all right? So I'm gonna be pulling just with my hands here, okay? Ooh, lost my pulley there. And that looks pretty good like that. So just my hands are knowing to pull with the right amount on the string here. I'm gonna back out a little so you can see what I'm doing right now. I'm just holding it, okay? And it is, I don't know, on this marking like 102 or so. So I'm gonna go put this right here. I don't know. I gotta try to do two things at once. Tighten this down. Then I'm gonna put it, oh, whoop, it's going crazy. All right. That could work. That's not too bad. I'm a little over, but it's, let me see if I can, these little pulley wheels, the little screw on the bottom is going into little divots that are on the underside. Does that look better? Not really. I think I'm being a little too picky here. Okay. Now that I got the angle, now I got to figure out what kind of mass is going to work for me. And this is just trial and error. So you know what? I'm going to try 200. I have no idea. Too much. Okay, I hung 200 and it's now hitting this side. So that's too much. So I'm going to have to go, and I'm running out of weights actually here. I'm going to have to steal another one. That's a good deal that I've got enough of these weights sitting around. I got a 50 and another 50. That ain't enough. I gotta steal another one. Okay, here's another 50. Ooh, did you see? So now that's too much. It's again hitting. Did you see that? It's hitting. It's going back. So 150 is too much. So I'm gonna take one of these off. So I know it's more than 100, less than 150, and now I get the cute ones out. So here's a little 20. Let's see. That didn't move it. I got another 20. That again is a little too much. Okay, so I'm gonna take off that 20. And I got the little tensors. I sometimes want to make little earrings out of these. They're so cute. Okay. Ooh, that's not bad. Do you see that ring? It's pretty much free floating. All right. So let me back out so you can see all the craziness that's hanging from here. So down here, I have a 50, a 50, a 20, and a 10 hanging from there. If this didn't work out perfect, realize 10 grams, when you change it to newtons, it's not that much compared to our total, right? We're not going to have, if I needed a 5 gram, for instance, the difference between 5 and 10, 5 grams out of 150 is a pretty small percent error as things go. So if this wasn't all pretty, it would still be in the realm of a decent lab. Okay, so now we have to record, and you're going to have to figure this out. Based on what we called the other numbers, you are going to have to figure out what angle we have. I called this 0. I called this 120. So I'm going to zoom in here. You're going to look and determine what angle to call that. All right? Realizing that 90 we would normally call 270. All right? And you're going to figure out what angle that is and what force is being pulled on there. Okay? And then we are done with part 3 after you do the calculations. All right. So now we are going to do trial 4. And trial 4 is like trial 3, except for now we have 4 forces. So we have 3 forces that are going to make up the resultant force. And then the 4th force is going to be the equilibrant, which is going to be equal and opposite to that resultant to undo or equalize those 3 other forces in the pulleys. So let's set this up. So I'm reading the lab, and it says in this trial of 4 pulleys, place pulley A at 350 degrees. Now 350 degrees in our world would be 10 degrees south of 0. Okay, so that's what I did. I put that there, and it says hang a 200 gram mass from it. So that's what I'm going to do right here. There is, ooh, I don't like that. It is hitting. Well, it is hitting a little bit. Let me see if I have a shorter 200. This one. It was hitting the leg of the table, and we don't want that to happen. That would be bad. There you can see a little. See, it's just making it there now. Okay, so that's the first one. And then place pulley B at 90 degrees. Well, 90, right? 90 north from our 0. So I'm putting it what is marked on this thing at, just not like staying there, at 270. And I'm gonna put that, and then I'm gonna double check. I'm gonna hang 250 from it. So I have a 200 gram mass and a 50 gram mass. I know you can't see it, so you have to have faith that I'm hanging that on this back side. And we can see it definitely pulling this ring when I just did that. And then pulley C is gonna be at 240. And so that means I need to move this guy here. And 240 really will mean 120, right? 240 is 60 degrees south of west, right? And so it would be at this location. I keep double checking. I don't like how this is not using the numbers we're used to. Okay, and I'm going to put this, ooh, there's a lot of force going on here. I can feel it. I wish you could feel it too. We're gonna hang 250 off of that one. Okay, so here's a 200 right here, it's marked right there. There's 200, and then I need a 50. Okay, I'm always double checking so I don't screw it up. Okay, and you can you see it hanging there now? All right, and now we got to do the whole guessy game thing again. So I'm gonna get, maybe not take that out. I need pulley number 4 here, ready to go. And it says estimate the angle of the equivalent pulley D. This is my D. I'm going to grab that string. Ooh, and I got to figure out which way. Which way? Well, you know what? Guess what? It's not going to be in this region here, and I kind of got this set up wrong, right? So let me quickly see, I'm showing you all the kinds of things be happening here. So I'm going to hang these quickly off of this one. And now I realize, where do I got to pull? I got to see me kind of playing with it. I'm going to zoom in again so you can see the ring a little bit more. I'm playing where do I got to go? See me slowly moving here? All right. It feels like this right here. All right. Okay. Oops, sorry. Oh, I gotta tighten this guy down. It's totally loose. I'm gonna play with it again. Now that I got it a little bit tight, I'm gonna get this right. Yeah. I think it's like there. A little scooty scoot. Okay. All right, now I have that. But now, still, I'm gonna scoot it over just a touch. It doesn't really want to be too cooperative. There we go. Okay, so now I am pulling on this, right, to get just the right amount of tension, but we don't know, my hand can't measure that, right? We need to know how many newtons of pull, so again, we have to turn this into weights. I have no idea. I'm gonna stick a 200 here. Is that gonna be it? Way too much. Okay, I'm gonna stick a 100 here. Oh, look at that. Do you see it's still too much? 100 ain't gonna do it. All right, 100's too much. So I'm gonna get my friend 50 here, okay? I'm gonna hang the 50 right from here. And what do I got there? Let's see. All right. It's close. I think it's not quite centered. I think, let's see what I can do. I don't know. I think that might be it. Did you see that? I put a 20 with it. I think it's somewhere in between. Here's with a 10. Okay, can you see that? I don't think we're gonna quite be able to. You know what? I think we're gonna go with 10. I think we're gonna go with 10. somewhere in between. Okay, so right here, I have 50 and 10 hanging from this angle, and I'm going to zoom in for you, all right? And so allow you to see, right? You need to be able to read what that angle is. Remember, this is 180, but this way would be increasing. So you just need to be able to record how many degrees it is added to that 180, okay? All right, okay. That is going to be all the data collection. Now the tricky part is being really, really careful about making sure you do correct sine and cosine, realize when our angles are going to be negative, our x and y components are going to be negative, and make sure everything makes sense. Remember that the equilibrant is going to be equal and opposite to the resultant of the 2 or 3 vectors that you have, okay? And careful, remember, equal and opposite means be careful with that angle that comes out of that, all right? So this lab really is a more set up proof-wise in terms of being able to set up how it all works out, to proving that all those forces cancel out. Okay, enjoy.